All right, we have indefinite integration homework help, and we're going to do several of these problems. The first one we're going to look at is problem 3, the integral of quantity 6 plus 2x dx. For this, we can separate this integral into two pieces. So we have the integral of, I'm going to put the 6 on the outside, the constant, dx, plus 2 the integral of x dx. And taking the integral, we're going to have 6x plus 2, and we're going to take x raised, x to the 1 raised to the 1 power. So we take 1 plus 2, so the x to the 2 power, divided by the power we raised 2, so we divide by 2, plus our constant integration c, and canceling out, we're going to have 6x plus x squared plus c, and if we wanted to write this in more of a standard form, we would write that as equal to x squared plus 6x plus our constant integration c. So there we go, that's problem 3 worked out. Okay, what's the next one we're going to look at here? Look at problem 7. Okay, we have all these fractions. Well, I think it's going to be the same thing we looked at with number 3 pretty much. Only it's going to be more complex with the fractions and so forth. So we're going to rewrite this integral as 2/3 the integral of x to the 5th minus 5/2. You can always take that constant and bring it out front. X, and I forgot something here. I don't want to, especially when we're doing an initial thing, x to the dx, okay? Let's not forget that dx times all that. Minus 5/2 x dx, x to the first power, plus 1/2 integral dx. And so this, we're going to have 2/3, and x to the 5th becomes x to the 6th, and we're going to divide by 6. And so what I'll do is put this 6 in this denominator as this neighbor to the 3. Okay, and minus, we're going to have 5/2 x we raised to the power of 1, to the power of 2, and we're going to divide by 2. We call this technique, I've heard it called bump up and divide. We bump up the power of the exponent by 1 and divide by whatever we bumped up, and then we have plus 1/2 x, and plus our constant integration c. And now we just have a little bit of cleaning up to do. We're going to have 2 over 6 times 3. Well, that's going to be 2 over 18. So we'll call that 1/9 x to the 6th minus 5, and 2 times 2 in the denominator is 4, so minus 5/4 x squared and plus 1/2 x. I guess you could write that as x over 2, but we'll just leave it like this. So here we have problem 7 worked out. Okay. We're next going to go to problem 9. And here we have some negative exponents here. So, well, it's going to be a slightly different type of problem. So I'm going to try to rewrite this in what I call calculus-friendly form. So I'm just going to separate these first before we change that. So let's say equal to 2 dx minus 1 over x to the 5th dx plus, we have 7 on the outside, so that's 1 over x cubed dx. And I'm going to just continue straight to the right here with this. So we're going to keep 2 integral of dx the same, and then we're going to have minus. What we're going to do is take this 1 over x to the 5th and make this x to the negative 5th power dx. And then this 1 on this last term, we're going to have 7. And we'll say 7. This 1 over x cubed is going to be just x to the negative 3 power dx. Okay, we should be ready now to integrate. And the first one we have here, I'm just going to work straight down. I think we'll have enough room. We'll have equal to 2. And then this, we're going to have minus x to the negative 5th raised by 1 power is going to be x to the negative 5th. Negative 5 plus 1 is negative 4. And we're going to divide by negative 4. And then we're going to have plus 7 and x to the negative 3. Well, if we take negative 3 plus 1, we have negative 2. So we're going to divide by negative 2. And we have our constant of integration c. Okay, let's clean this up a little bit. We have 2 that comes straight forward, and we have negative divided by negative. So that's going to be positive. I'm going to write this as 1/4 x to the negative 4 power. And then we're dividing by a negative. So we're going to, that's going to end up being negative. So we'll have 7 halves x to the negative 2 power plus c. And to change this one more time so there are no negative exponents remaining, we're going to say 2 plus 1 over 4x to the 4th. That negative 4th power becomes positive 4th power when we drop that down to the denominator, minus 7 over 2x squared plus c. So there we have our integration with the x's to the negative powers. Okay, let's go on and look at our next problem. I think that's going to be problem number 11. Okay, we have, doesn't look like it should be too bad, an integral of 5 times the 5th root of x dx. So we're going to take this 5 outside the integral sign, and at the same time, this 5th root of x is x to the what power? X to the 1/5 power dx. And so what we're going to do in integrating now is we take 5 times x. Now we're going to have to add 1 to 1/5. Well, what's 1/5 plus 1? Well, 1/5 plus 1 is the same as 1/5 plus 5/5, right? 1 is 5/5, so we end up with 6/5. So we're going to have x to the 6/5 power, and we're going to divide this by 6/5. And we cannot forget the plus c, our constant of integration. So what we do is dividing by a fraction the same as multiplying by its reciprocal. So we have 5 x to the 6/5, and 6 to 6/5. Make it big enough so that's the 6/5 power. And instead of dividing by 6/5, we're going to change that around and multiply by its reciprocal, which is 5/6. And that's going to be plus c, and that's going to equal 5 times 5 is 25/6 x to the 6/5 plus our constant integration c. Okay. The next one we have on tap is number 14. Okay, we have this square, this x minus 5 quantity squared dx. And there's something we could do, possibly called u substitution, but not having learned how to do that yet. We're just going to expand this thing out. So we have the integral of, just expanding out, we're going to have x squared, and we're going to have negative 5x times negative 5x. We're going to have minus 10x, and negative 5 times negative 5 is going to be plus 25, and dx. And if you wanted to just take this x as quantity x minus 5 times quantity x minus 5 and multiply these all together, you'd realize we'd get x squared minus 10x plus 25, just some practice. And so now we can separate these guys into the integral of x squared dx minus 10 times the integral of x dx plus 25 times the integral of dx. And to integrate, we're going to take x squared, and this 2 plus 1 is x to the 3rd power, and we're going to divide by 3, and I think that takes care of that first term. Next, we're going to take minus 10 and x to the 1 power raised to 1 plus 1 is 2. So I have x squared over the power that we raised to and plus 25x plus our constant of integration c. And so now we're going to rewrite these expressions kind of simplifying. So we'll have 1/3 x cubed and minus 10 divided by 2 is 5. So we'll have 5x squared and plus 25x plus our constant of integration c. So this will be our answer. I think from 14 we're going straight to 18. Okay, we have kind of a little bit of complication of a root thing here with this dividing by this square root of x. So let's go ahead and try to make sense of all this. What we're going to do is the same thing we did in our last problem we looked at, 14 I believe it was, where we're going to expand this guy out. So in the numerator. So we're going to have equal to this 3x squared is going to be 9. 3x squared is 9x squared. And then we're going to have negative 2 times 3x, which is going to be, I believe, negative 6x. And then let's just put this over here. 3x minus 2, 3x minus 2. Yes, we have in our FOIL we have 9x squared, and this will be minus 6x, and then we're going to have negative 2 times negative 2, which is 4. So let's just go ahead and write this as minus 12x and plus 4. Okay, and this x, the square root of x, is going to be x to the 1/2 power. Make sure I have that visible. X to the 1/2 power. That's the square root of x. And all this times dx. Alright, so what we have, I'm going to continue to work to the right, is we have 9 I'm going to split these up too. And we have x squared divided by x to the 1/2. So that would be x to the 4 halves divided by x to the 1/2. So we're going to have x to the 3 halves power dx. And then we're going to have minus 12x. So we're going to say minus 12. We'll say x to the 1 power, x to the 2 halves, divided by x to the 1/2. So that's going to leave us with x to the 1/2 power dx. And then we have plus 4 divided by x to the 1/2 power. So that's going to be 4x to the negative 1/2 power. When we bring this x to the 1/2 power up in the numerator, it becomes the negative 1/2 power dx. So now we have something we can work with, I hope. So we have equal to 9 x to the 3 halves plus 1 is going to be 5 halves. And we're going to divide by what power we raised to, which is 5 halves, minus 12, and this x to the 1 half, we add 1 to it to make this to the 3 halves power. X to the 3 halves power, divide by 3 halves. And then we have this 4x to the negative 1 half power. So I'm going to say plus 4, and negative 1 half plus 1 is going to be 4x to the 1 half power. And we're going to divide by 1 half. And we have our constant of integration c. Now, I'm going to try to wrap this up down here below. We're going to have 9 x to the 5 halves, and dividing by 5 over 2 is the same as multiplying by 2 over 5, minus 12 x to the 3 halves, and instead of dividing by 3 over 2, we're going to multiply by 2 over 3, and then we have plus 4x to the 1 half, so that's going to be 4. Put that back in radical form, x to the 1 half. And instead of dividing by 1 half, we're going to multiply by 2 over 1, which is the same as multiplying by 2. And that's going to be plus c. Okay, multiplying by 2 and plus c. And just kind of simplifying out, I think we have some room left on the right to work with. This is going to be equal to 9 times 2 is going to be 18 fifths x to the 5 halves power and it's going to be, we have negative 12 times 2, which is 24 divided by 3, so that's going to be minus 8 x to the 3 halves power. And then we're going to have 4 times 2 is 8, so plus 8 x to the 1 half power, which is square root of x, plus our constant of integration c. So a lot of opportunities to make little mistakes in there. You work this out. If you caught any mistakes, especially in this last one, let me know. Now we're going to go to problem number 25. Solve the following differential equations. I think I assigned problems 25 and 26. So what we have is, it's kind of hard to see here, but what we have is we have f double prime of x is equal to 2. That's what this says. We have f prime of 1 is equal to 4. And we have comma f of 2 is equal to negative 2. So that's what we have to work with. And I think it's mainly, a lot of this is getting off on the right start. So what we have is f prime of x is equal to the integral of f double prime of x dx. So what we can do is substitute in f prime of x. And so you see this f double prime of x? We can substitute in 2 for that since we know this is 2. So if we come over here, we're going to have f prime of x is equal to the integral of, we replace this f double prime of x with 2 dx. And what that's going to be equal to is 2x plus c. So I'm going to come over to the left here, working in purple. We have f prime of x is equal to 2x plus c, the constant integration c. Well, we happen to know that f prime of 1 equals 4, so we can set this f prime of x, we'll set this equal to 4 instead of f prime of x. We replace that with 4 equals 2x plus c. Well, x is 1. See, that's 1, x, y, x is 1, y is 4. So 2 times 1 plus c. And what we have is 4 equals 2. 4 equals 2 plus c. So c is equal to 2. So what we have is this f prime of x equals 2x plus c. This is the general solution. The particular solution is f prime of x equals 2x plus, and we know that c is 2, so we have 2x plus 2. So f prime of x equals 2x plus 2. Next, we know that, or should know that f of x is equal to the integral of f prime of x dx. So what we can do is replace, see, we have f prime of x right here, so we can take this 2x plus 2 and substitute it in the place of f prime of x dx. So we take, I'm just going to write the equation down below here, f of x is equal to the integral of, replacing this with 2x plus 2, we're going to have 2x plus 2, make sure I have it there, 2x plus 2 dx. And that is going to be equal to, we'll say 2 times the integral of, taking this 2 outside, x dx plus 2 dx. And integrating, we're going to have, bringing this the right down here below equals, we're going to have 2, and this x to the 1 power, we raised 1, so 1 plus 1 is 2. So we have x squared over 2 plus 2x plus our constant of integration, c. And so that's going to be equal to, 2 over 2 cancel equal 1, x squared plus 2x plus c. And that's what we're going to simplify from. And remember, this is going to be f of x is equal to x squared plus 2x plus c again. Though this is a general solution, we want a particular solution. And to do that, we have f of 2 equals negative 2. So that's the y value is negative 2. So negative 2 is equal to, we substitute every place we see x with 2. So we're going to have, instead of x squared, we'll have 2 squared plus 2 times 2 plus c. And that's going to be equal to, let's see, 2 squared is 4 plus, let's put 2x. I should have put 2 times 2 right here. See that? 2 times 2, because that's x squared plus 2x plus c. So we have 2 squared is 4 plus 2 times 2, that's 4. So we have 8 plus c. So we have negative 2 equals 8 plus c. And if we subtract 8 from both sides of the equation, we have, therefore, c equals negative 10. And so we're going to take our particular solution, and I've kind of run out of room. Let me just go down below. We're almost there. We're going to conclude with our particular solution, f of x is equal to x squared plus 2x plus our constant of integration, which is negative 10, so minus 10. So this is going to be our particular solution, and we had to work our way to get this. So I hope this has been helpful. You'll be able to understand everything going on here and get most, if not all, of your remaining homework assignment completed. Thank you for viewing.